So for this first one, they give us the slope field, and they're asking which one of these equations matches with it. And essentially, it's just which one of these would follow along with these slopes. And if you were to draw in, a solution going along with these slopes, it would look something like that, which is your LN graph. So that one's going to be E. And if you wanted to test any of the others, like the x squared, like a parabola, it's going to go against the slopes. And you can see that for any of the other choices. So it's the one that's going to follow along with the slopes that are given. All right, number 2 is a differential equation. So solving that, we're going to divide over the y and then multiply over the dx. And then do the antiderivatives. And so the left side is going to be ln, and the right side is going to be 4x plus c. And they tell us that y is 4 and x is 0. So if y is 4, this is just going to be ln of 4. And if x is 0, then that will just be our c value. So I'm going to go back a line and just copy that exactly, except instead of plus c, I'm going to put plus ln of 4. And then to cancel out the ln, we're going to exponentiate this whole thing. So we will get y equals, and then over here, the e and the ln are going to cancel. So we're just going to have a 4 as our coefficient, and then it would be e to the 4x. So 4e to the 4x. So that one is A. Right, these next few are the Euler's method questions. These may show up as non-calculator, so you have to try your best to fight your way through them. I'm going to let you just use a calculator on the test for me, because I know that this is tedious. It's not like necessarily hard, but it is a very tedious thing to get through. So we'll see how bad these are before I reach for a calculator here, because sometimes they can become quite a mess. All right, so here's our differential equation. It's just x plus y. The initial condition is 1, 2. So I'm going to go ahead and put that in my chart. We're going to start at 1, 2. What is the approximation for f of 2 if Euler's method is used starting at 1 with a step size of a half? So I'm going to count by halves here. So this would be 3 halves, or 1 and a half, 1.5, however you want to write that, and then 2. And so whatever lands here, that is going to be my answer. So for this first box, it's where you started, so 2, plus the step size, and what we were counting by was a half, and then times the slope, which is x plus y. So from the previous point, if we add x plus y, we're going to get 3. And so let's see, that's not too bad. This would be 3 halves plus 2, so that would be 7 halves. So basically 3 halves plus 4 halves would be 7 halves. All right, and then so for the next one, it's where we just were, so 7 halves plus the step size, so what we're counting by, and then times the slope, which is dy dx is x plus y. So we want to add these together. So 3 halves plus 7 halves would be 10 halves, which would be 5. And so what is this? 7 halves plus 5 halves, that would be 12 halves, which would be 6. So 6 for that, and so that one is C. So I made it through without a calculator, yay. All right, number 4. Given that y of 1 equals -3, so 1, -3 is where we're going to start. This is our differential equation, so that's going to give us our slope. What is the approximation for y of 2 if Euler's method is used? Step size of a half starting at 1. So again, I'm going to count by halves. So this will be 3 halves. This will be 2. That's what they asked us for, y of 2. So again, whatever lands here is going to be our answer. So this one is going to be where we just were, so -3 plus the step size, which is a half. That's what we're counting by. And then times the slope. So we have to plug in these numbers to the dy dx. So if we put in 1 for x, that'll be 2 plus -3, which would be -1. So that is going to be -3 minus a half. So -3 and a half, -3.5, or should I do that as halves, -7 halves? Either way, -3 and a half. All right, and so this one is going to be where we just were, so -7 halves plus a half, which is the step size, times the slope. All right, so if we put in 3 halves for x, the 2's are going to cancel. That would just be 3 plus the y. So 3 minus 3 and a half, that would be -a half. All right, so this is -7 halves minus a fourth. And so, oh gosh, what is that? -14 fourths minus 1/4, so -15 fourths. And oh gosh, what is that? Let me do that. -15 fourths, so -3.75. So that one is D. All right, and so 5, we've got one more of these. This time we're given a table of values for the derivative. So there's g prime. We're starting here. G of -1 is -2. So -1, -2 is our starting point. We're trying to approximate g of 2. Where does it say our step size? So it's so small here. Step size is 1 and a half. All right, so if we add on 1 and a half, that is going to be a half. And then adding on 1 and a half again, that'll give us 2. And that's the one that they asked us for. So whatever we get here will be our answer. So this one is going to be where we just were, so -2 times the step size, which was 1 and a half, or 3 halves, and then times the slope. So that would be g prime at the previous point. Now all they give us is the x value, so I just need the x value from the previous point, which is -1, and so that slope is going to be 2. All right, and so these 2's cancel. We'll have -2 plus 3, which is 1. All right, and then last one, I know these are so tedious, you just have to get through it. All right, it's where we just were, plus the step size, which is 1 and a half, times the slope at the previous point. Now the x value was a half, so I'm going to find that on my chart. Here it is, and so that slope is 1. So I've got 1 plus 1 and a half, that would be 2 and a half, or 5 halves. Oh, of course they wrote it as the decimal, I wrote it as the fraction. So that one is also D. All right, enough with Euler's method. Let's move on to something else. All right, a puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. The weight of the puppy during the first 6 months is increasing at a rate proportional to its weight. So that's the part that tells you this is exponential, is proportional to its weight. How much will a puppy weigh when it is 3 months old? So this is your formula for exponential growth. And C is the initial weight, so or the initial amount, in this case it's weight. So puppy weighs 2 pounds at birth, so C is 2. Right, and then it says that the puppy weighs 3.5 pounds 2 months later. So the weight is going to be 3.5 when time is 2. So I put in 3.5 for the weight, time is 2. We're going to have to solve for this K value. Right, so I'm going to start by dividing over the 2. So this will be 1.75 equals e to the 2k. All right, and then we're going to ln both sides. So if you want to see what I'm typing in here. So I'm going to type in ln of 1. Oh, it should be 1.75. I'm sorry. I think that's what I said. My hand put an extra 1 in there. 1.75. I apologize. All right, so ln of 1.75 gives me this crazy decimal, 0.559. Sorry, it's hard to have the calculator and my paper up here at the same time. Equals 2k, and then we're going to divide this by 2. So divided by 2, and so that is the k value, 0.279. Now I'm going to need to reuse that, so I'm going to store that as a. So store alpha a, enter. And so my equation is y equals 2e to the 0.279 times time. And then they're going to ask us what is the weight at a certain time. So let me see what we're plugging in for that. So what is the weight of the puppy when it is 3 months old? So we're going to put in 3 for time and get our answer. So I'm going to type in 2e to the power alpha a, that's stored value, times 3. And so that is the puppy's weight at 3 months. So 4.6 pounds. And so that one is B. All right, 7, population Y grows according to, all right, this tells us that this is exponential growth. We have K times Y. K is constant, times measured in years. Population doubles every 10 years. So find the value of K. So again, we've got Y equals C e to the KT. That's our, exponential formula. I don't know what this C value is to start with, but they're telling me that it doubles every 10 years. So like, for example, if C was 1, then the result over here would be 2. Like whatever it is, you're going to get double that. So we're going to have 2 equals E to the K times, what was it, 10. I said it doubles every 10 years. So I'm going to put in 10 for time. All right, and then we're going to ln both sides. I'm not even going to try to put the calculator up there at the same time because it's just not going to fit. But I'm typing ln of 2. And that gives me 0.693 equals 10K. And then I'm going to divide that by 10. So I just hit divided by 10 in my calculator. So 0.069, which I don't know why I hit divided by 10. You're just going to move the decimal point over when you, divide by 10. So 0.069, and so that one is A. All right, number 8. Bacteria in a culture are increasing. It says at a rate proportional to the number present. That means it's exponential. So again, we're going to have, y equals C e to the KT. What else is this here? The number of bacteria doubles in 3 hours. So it's kind of like the one we just did. Whatever you start with, it's going to double in 3 hours. So I'm going to have 2 equals e to the k times 3. So when 3 hours go by, it's going to double. And it says, in how many hours will the number of bacteria triple? All right, well, so first we have to get this K value here. So I'm going to ln both sides. And you know what? I'm not going to type that in the calculator because all these choices here have, ln's in them. So I'm going to write ln of 2 equals 3K, and then we'll divide by 3. So that weirdness, that's our K value. So let me plug that back in up here. We're going to have Y equals C e to the ln of 2 over 3 times time. And remember, that's just some number. I know this looks like crazy notation here, but if you type this in, you just get some decimal. And then the question is, how many hours, so we're looking for time, will it take for it to triple? So whatever this starting amount is, we want it to triple. So we would have 3e to the, all of this, times time. And then we're going to ln both sides to get rid of the e. And then to move this over, we would multiply by the reciprocal. So we're going to multiply by 3 over ln of 2 to get that to cancel out. So this would be 3 ln of 3 over ln of 2. Let's see which one that is. 3 ln of 3 over ln of 2. That is A. That one was weird because you had to leave it with all the ln's in there, so it ended up looking really crazy. All right, number 9. The number of moose in a national park is modeled by a function m, so here's m for moose, that satisfies the logistic differential equation, this thing. All right, so the 0.6 is the K value, and then that 200 is the carrying capacity. So what that means is the amount of moose is going to level off at 200. So the environment can support 200 moose. All right, time in years, there at time 0, there are 50 moose. What is the limit to infinity? Well, the limit to infinity is going to be the carrying capacity, so that's going to be the 200. So that would be B. So we didn't have to do much with that. Basically, it was just asking you what the carrying capacity was, which is nice. All right, which of the following is a slope field? So you would basically just test them all until you get one that works. Maybe to like narrow this down here, everywhere that x is 0, you would have 0 slopes, and everywhere that y is 0, you would have undefined slopes. You know, I don't want to take like too long to go through this. This one would be E, and you can see that if you start to, you know, plug in some numbers and match it up. I would maybe look at like 1, 1, or 2, 2, or 3, 3 for this. Do you see how the slopes are 1 there? Because if you plug in the same number for x and y, you're going to end up with a slope of 1, so you can maybe kind of match it up that way. But you can just see that the other ones would not match that. You could just pick a couple of points to test to match them together. All right, and then this one's similar, just going the other way. This time you have the slope field and you're going to match to the differential equation. What I would do is look at this one where the slopes are 0. So anytime x is -1, you're going to get a slope of 0. And so that's going to match with C. If you put in -1 for x, you would get -y plus y, which is 0. So that'll give you all the 0 slopes. Again, it's just matching, and you could test the others and show that they don't match up with those. All right, so here's another logistic equation. The carrying capacity is 200. So actually, it's kind of like that news question. All right, which of the following differential equations for population P could model the logistic growth shown in the figure above? I'm sorry, it's so small for you to see. All right, so dp dt is going to equal kp 1 minus p over 200. So 200 is the carrying capacity. So you have K times the population, and then 1 minus P over the carrying capacity. So what they've done here is distributed this through. So this would be KP minus, and then you would end up with a P squared. So what would that be? Minus K over 200 P squared. And so this allows you to narrow it down because I think only 2 choices have a P and then minus and then a P squared. I think all the rest of them are backwards. Yeah, the C, D, and E are all backwards. So you could even narrow it down to, you know, 50-50 shot. There's no way of figuring out K, so just I would look at the 2 choices that are here and just test one to see if it works. So if we let K be 0.2, we would have 0.2p minus, and then if you did 0.2 divided by 200, you would get this 0.001p squared. So if you try it for letter A, it's going to work. So A is going to be your answer here. If you try that for letter B, it's not going to work. If you make K be 0.1, when you do 0.1 divided by 200, you don't get this. So, so I would narrow it down, and then out of the 2 that are left, this is a really hard problem because they don't give you much information at all. You pretty much just need to look at the choices to see which one will work out. I didn't really like that question. It didn't give you much to go on at all. You kind of had to be a detective and figure it all out for yourself. All right, here's another matching one. Which slope field goes with this? Now this only has a y in it. So that means all of the rows will be the same. So it could be A, all those rows are the same. Could not be B, it could not be C, it could not be D, but it could be E. E has rows that are all the same. So we've narrowed it down to those 2. Just glancing at A, it looks like we have, oh, whoops, I drew on it. It looks like we have horizontal asymptotes at 1 and -1. So let's see if you plug in 1 or -1, you know, that's going to work out. It's going to be A. If you plug in 1, you're going to get 0. And if you plug in -1, you're going to also get 0. So you would have these 2 horizontal asymptotes here. All right, and then last one. dy dt equals ky. This means exponential growth. K is a non-zero constant. then y could be. All right, so it's basically which one of these follows this pattern in some capacity. So let's see, it can't be this one that has an extra y in it. It would have to be B as your answer there. So it's just seeing which one matches the exponential growth equation.